Since the dawn of time, the Moon has been our faithful celestial companion. But other planets have satellites too, and often more than the Earth. The silent companions of the planets are fascinating worlds in their own right, and some may even be candidates for extraterrestrial life.
At first sight, moons seem like a pretty simple affair. Moons orbit planets, and each planet has at least one of them. But in fact, things aren't quite that straightforward. Incidentally, people in earlier centuries were far more poetic. Kepler, for instance, reckoned that moons are there to provide the inhabitants of the planets with light at night and afford them the spectacle of their rising and setting. That's how people thought back then. Today, we think that in the future the moons will provide us with raw materials and serve as a base for colonies. But what interests us today is, what actually are moons? How did they form? And could they even be home to primitive life?
Everything in the universe is in motion. The Milky Way revolves around its center, and with it, our sun. The planets orbit the sun. Moons accompany those celestial bodies that orbit a star. This is why moons are also referred to as satellites, which means companion. We haven't yet discovered life on any moons, but then again, we've only actually investigated a handful so far. The Earth's moon was visited by the Apollo astronauts. A probe has landed on the Saturnian moon Triton. Of all the others, we have only photos taken through telescopes or by passing space probes. High time we explored those moons more thoroughly. Not all moons are alike, quite the contrary. Ganymede is frozen and huge, bigger than the planet Mercury, in fact. Titan has a dense atmosphere and landscapes with mountains, rivers, and lakes similar to the Earth. Io is as colorful as a pizza and covered by active volcanoes. Enceladus is only medium-sized, looks like a ball of ice, and ejects icy plumes out into space. But it's a sphere, at least.
The moons of our solar system, especially the ice moons, are some of the most fascinating objects in our solar system, and especially since we discovered signs that there may be oceans beneath their frozen surfaces.
It isn't proven, but neither can it be ruled out that life may well have arisen in the oceans of some of these moons.
In order to be as spherical as our moon, a moon must accumulate quite a lot of material during its formation. Otherwise, it won't have sufficient gravity to form a sphere. Only a few moons had this much mass during their formation. The smaller the moon, the more irregular its shape. The Martian moon Deimos, for example, is tiny and looks like a potato. But planets aren't the only bodies that have moons. Many dwarf planets and even asteroids have them. With their modern instruments, researchers have discovered several hundred moons in our solar system that orbit planets and asteroids.
So how did all the planets and their moons form all those eons ago? Well, let's take a look at the situation 4.6 billion years ago. This is it. There was a rotating disk composed primarily of hydrogen gas and dust particles. These dust particles collided with one another and formed even larger objects we call planetoids. There were larger and smaller planetoids, and dust disks around these planetoids. And it's from these dust disks that the moons formed. Another thing that happened was that the larger planetoids captured the smaller ones. Other moons formed in this way. Right at the end, the following happened to Earth. As the planets had already formed, a relatively large planet, roughly the size of Mars, smashed into our Earth.
auf unsere Erde ein.
And this is probably how our moon came into being.
Theia. This is what astronomers christened the planetoid that hit the Earth in the early days of the solar system. It must have been a spectacular event. This collision created the Earth and the Moon, which then cooled down over the space of several billion years to become the objects we know today. That's the generally accepted hypothesis.
I think all of my colleagues agree that there was a massive collision between the Earth and another object the size of Mars. Not head-on, more of a glancing blow. The Earth was ripped open and a great deal of material was ejected from the Earth into orbit, where it coalesced to form the Moon.
The Moon is the celestial body that is closest to us, and the one we are most familiar with. Since the dawn of mankind, people have gazed up at the Moon. It has always fascinated them. The Nebra sky disk, which was found in Saxony-Anhalt in Germany, was made by Bronze Age people around 4,000 years ago. The full moon and the waxing moon are the most prominent elements. As if people back then realized the fundamental importance of the Moon for life on Earth, namely, due to its gravity.
For one thing, it guarantees our seasons. The seasons are a consequence of the Earth's axis being tilted by around 23 degrees. The Moon orbits the Earth and stabilizes this axis. If the Moon weren't there, its axis would slowly tip over and there would be times when we'd have no seasons at all. So the Moon ensures that we enjoy relatively stable conditions.
It stabilizes our axis, which would otherwise wobble around a bit as it gets pulled by Jupiter and then by the Sun. But the Moon acts a bit like an outrigger on a canoe, and is why our climate actually remains fairly constant.
The Moon is also responsible for the tides. Who knows whether there would be life on Earth at all without the ebb and flood? The intertidal zones in particular provide ideal conditions for it, and it's presumably from these shallow zones, sometimes flooded, sometimes dry, that the first life forms crawled out of the sea and onto land.
The intertidal zones are replete with the nutrients required for life, so it's probably where life actually first arose. And without the Moon, these large movements of water wouldn't have happened, and life may not have developed.
The Moon, with its phases, is the clock by which our calendars are set, and where the word month comes from. A month originally designated the time it takes the Moon to go through all phases, from one new moon to the next, in around 29.5 days. The Moon regulates life on Earth, as it were.
The repeating, regular, cyclical events, they all have something to do with the Moon. As such, it has a big influence on our experience of reality, the order of events. Apart from the years, it demarcates time. And for me, that all makes it a trusty companion I love to look at. I'm always reminded of the song by Matthias Claudius, Der Mond ist aufgegangen, or The Moon has risen.
The Moon is the only extraterrestrial body that humans have set foot on to date. When the Apollo astronauts from the USA flew to the Moon 50 years ago, it was not so much out of a desire to explore. It was primarily to show the Soviet Union who was ahead in the space race. But they nonetheless brought back a large quantity of Moon rocks, the analysis of which revolutionized our knowledge about the Moon. It's only since probes and astronauts have circled the Moon that we know that the front and backside are completely different. The front is characterized by large, dark patches, huge lava plains. We don't find them on the backside. It consists mostly of elevated plateaus full of impact craters. The fact that it's like this is related to how the Moon was formed. Perhaps future astronauts will shed more light on the matter when humans return to the Moon. NASA's preparations for this are already at an advanced stage. They intend to use the Moon as a staging post for journeying deeper into space.
The Americans have this program they're now calling Artemis, the twin sister of Apollo, among other things, to indicate that this time female astronauts will fly to the moon too. This Artemis program encompasses a whole range of different concepts. There's the Lunar Gateway, a kind of bus stop orbiting close to the moon from where it's easy to descend to the lunar surface, and that can only be used as a staging post. It's a big program, and NASA naturally imagines it being the stepping stone to Mars.
At present, the International Space Station is the most important multinational space program. The European Space Agency, ESA, can imagine a base on the moon, the so-called Moon Village, as its successor.
I think a good way to imagine the Moon Village would be using the analogy of an Antarctic research station. That gives you an idea, but it goes beyond that. The Moon Village concept is much more extensive. It can allow for things like developing technologies relating to energy provision, for example, and even tourism. Who knows? So the concept of the Moon Village is explicitly being kept open. It should remain open for different purposes for technicians and, of course, scientists and researchers.
But is it really worth flying to the moon? Except perhaps for research purposes? The mining of helium-3, a possible future source of energy, for instance, would be extremely costly.
The moon is a bit like an extra continent, and I'm sure we'll at least use it sooner or later. But whether we really will permanently settle there are a great many difficulties in doing this. But we will fly there again, I'm pretty sure of that. Apollo showed that a 3-day outward journey, 3 days there and 3 days back again, worked perfectly. And 100 years ago, you couldn't even get from England to America in 3 days. But I'm sure that when there's a base on the moon that can comfortably accommodate people for 3 days, tourism would be an option. I mean, if you actually had a shuttle to the moon and said we'll be able to fly there in 10 years, I reckon it could already be sold out today.
We haven't known for all that long that there are other moons out there besides our own. In 1610, the Italian scholar Galileo Galilei pointed his home-built telescope at the planet Jupiter. He discovered that this planet had 4 companions.
It was an earth-shattering discovery that these moons behave the same way with respect to Jupiter as the planets do with respect to the Sun.
In this way, Galileo indirectly confirmed the heliocentric worldview, with the Sun in the center instead of the Earth. Io, Europa, Ganymede, and Callisto. The Galilean moons are named after lovers of the Roman god Jupiter. Hundreds of other moons have been discovered since Galileo's time. We now know of 79 Jovian, 82 Saturnian, 27 Uranian, and 14 Neptunian moons. The inner rocky planets, Mercury, Venus, Earth, and Mars, on the other hand, only have 3 moons between them, our own and 2 that belong to Mars. Which raises the question, why is this?
Why do Mercury and Venus have no moon? The Earth just one, and all the other planets out there more. Even the dwarf planet Pluto has 5 moons. Why is this? Well, it's a question of a moon's orbital stability. I should explain that in more detail. Let's assume we have the Sun here. And a planet here. This is the line connecting them. Now we'll take a random point in between, say here. The question is, how much stronger is the pull exerted by the planet compared to the pull exerted by the Sun? Here, the pull of the planet is greater, so the moon feels attracted to the planet. If I take this point, the opposite is true. The pull toward the planet is less than toward the Sun. So somewhere in between is a boundary which defines a sphere within which moon orbits are stable. This is called the Hill sphere. Now here's the thing. The closer a planet is to the Sun, the smaller the Hill sphere is, because the gravitational force of the Sun increases. So Venus has a very small Hill sphere, which is why it's very unlikely that Venus has a moon. The same is true for Mercury. But the further out I go, the bigger the Hill sphere becomes. This is the reason why every dwarf planet like Pluto can have so many moons. In fact, every celestial object has a Hill sphere, which is why we even see asteroids with moons. And in principle, even moons can have moons. But alas, we have yet to observe such a phenomenon.
Aber sowas hat man leider bisher noch nicht gesehen.
When it comes to the small rocky planets Mercury, Venus, Earth, and Mars, we only find a few moons. The Earth's moon is special because of the unusual way it was formed. It is one of the largest moons in the solar system. The two Martian moons are tiny in comparison. Our moon circles the Earth at a distance of approximately 385,000 kilometers and has a diameter of 3,500 kilometers. It takes about 27 days to complete one orbit. The two Mars moons are much smaller, much closer to their planet, and orbit it much faster too. Phobos has a diameter of just 22 kilometers and is only 9,300 kilometers from Mars. It takes just 8 hours to orbit it once. Deimos is only 12 kilometers across, but it is further out at 23,500 kilometers from Mars, which it orbits in 30 hours. If you were to throw a stone on Deimos, it wouldn't fall back, but enter Mars' orbit and so become a satellite in its own right. Phobos and Deimos, in English fear and panic, the companions of the god of war Mars, were only discovered in 1877. Phobos races across the Martian sky. It rises and sets twice each Martian day, whereby a Martian day is almost the same length as a day on Earth. Where Mars got its moons from is unclear.
According to one hypothesis, they're captured asteroids from the asteroid belt that lies between the orbits of Jupiter and Mars and contains a vast number of small objects. Something was kicked out by Jupiter's gravity and got close enough to Mars to be captured by its gravity. On the other hand, it could be that Mars suffered some large collisions. We can see some massive indentations on its surface, impact basins. Obviously, material must have been ejected, and it's possible that it couldn't escape Mars's gravitational influence, was captured, and that's where the two moons came from.
Perhaps the question will be answered in the second half of this decade. This is when the Japanese mission, Martian Moons Exploration, or MMX for short, will study the Martian moons and bring samples back to Earth. During the mission, a German-French lander is to be set down on Phobos. The fate of the Martian moons is sealed anyway. Phobos is slowly getting closer to its planet and will someday, millions of years from now, crash into it, whereas Deimos is slowly retreating from Mars and could one day, in the even more distant future, escape it. But before this happens, a Martian moon could still have an important role to play for us.
At
the end of the 1950s, a German aerospace engineer once said, if God had wanted us to explore space, he'd have given us a moon. And he was absolutely right, because our moon is just a 3-day flight away, and thus the perfect proving ground for demonstrating that we've mastered the technologies and can survive independently of the Earth. And if we someday want to fly manned missions to Mars, we don't want to make the risky descent to Mars right away. We need a staging post, which is why Mars' second largest moon, Phobos, is so important to us.
Perhaps one day, humans will travel even deeper into the outer solar system, to the gas giants. The planets Jupiter and Saturn have very different moons on offer than Mars.
Das sind wirklich ganz faszinierende Objekte.
They're absolutely fascinating objects. Many of these moons vent plumes of material that we can analyze. And what we find in them is water vapor and organic molecules. And this naturally makes them objects where we should look for life.
Wirklich Objekte sind, wo wir nach Leben suchen sollten.
Of the 79 known moons of Jupiter, many are just unremarkable little lumps of rock. Quite a number of them circle the planet in a swarm, a long way out. A single orbit takes 2 years, and they orbit retrograde, in the opposite direction to Jupiter's spin. Researchers have recently discovered even more candidates. There could be several hundred. But the focus is on the 4 large so-called Galilean moons. Io, the innermost, is also known as the pizza moon. The vivid colors are due to sulfur. It's the most volcanically active place in the solar system, which is why Io is the only large moon, besides the somewhat smaller moon of Earth, that isn't frozen over. Some volcanic eruptions extend far into space. The tidal forces of Jupiter cause Io's surface to bulge in and out by up to 100 meters.
Io gets heated up so much due to tidal friction with Jupiter that it's actually extremely molten inside and naturally exhibits an extreme amount of volcanic activity as a result. It has 1,500 active volcanoes, which is significantly more than we have here on Earth. They're all active, tremendously active. The eruption columns extend to a height of 300 kilometers. It depends on the size of the volcano, but the largest volcanoes, Halley and Prometheus, they can reach 300 kilometers, and the gas, at least, gets shot out into space. The solid matter doesn't go so high, but falls back and runs down the flanks, the way lava does on Earth.
Volcanism is widespread in the solar system, as we know from Earth. A volcano is like a valve. It serves to even out temperature and pressure differences between hot and cold regions. The interior of planets and large moons is very hot. The heat was originally generated as dust and gas coalesced to form these celestial objects. The decay of radioactive elements and tidal forces cause heating too.
Because space is cold, the surfaces of these planets and moons very quickly solidify, like putting a lid on a pressure cooker. So now it's hot inside and cold outside. The laws of thermodynamics demand that things reach equilibrium. And this can only happen if the hot material inside is transported to the outside. That's volcanism. So it's boiling inside, the lid is on, it gets hotter and hotter, the lid cracks, and then all the magma pours out onto the surface and then irradiates its heat into space.
Ganymede, the third moon, is a giant. With a diameter of 5,262 kilometers, it's the biggest moon in the solar system. It would even qualify as a planet. After all, it's larger than Mercury and is the only moon with its own magnetic field. Like nearly all large moons, Ganymede is an ice moon. Its surface is an icy crust, whereby there are ancient dark areas covered with craters and younger, bright ones with creases that appear very different. It's likely that beneath the crust lies an ocean.
Ganymede is a little bit further away. Jupiter's gravitational force isn't as strong, which means Ganymede's crust is thicker, but it has an ocean as well. The interior won't be quite as hot as it doesn't get squeezed and stretched quite as much, so we have to assume the ocean beneath the ice is at a rather early stage of development. And the crust will be so thick that there's probably no chance of getting at the ocean.
Callisto, the fourth of the Galilean moons, is also an ice moon. It looks dirty and is the most cratered object in the solar system. It too presumably has an ocean of water beneath its 200-kilometer thick ice crust.
Callisto is
so far out that Jupiter doesn't treat it as roughly as the others, and it's now pretty much frozen solid. When the ice is dirty, that is, it hasn't melted, it means it's a mixture of ice and dirt. As there's basically no atmosphere, the surface ice sublimes and the H2O or water molecules disappear, leaving the dust behind. That's why it looks so dark.
And then there's Europa, arguably the most interesting moon in the solar system. It probably has an ocean beneath its ice crust, too. All of these moons must have a source of heat. Otherwise, it would be impossible to explain the existence of phenomena such as volcanism and oceans of liquid water at such a great distance from the sun.
So moons can heat up. The question is, where does the heat come from? To find out, we have to take a closer look at a moon. Here's such a moon. A moon is subject to the gravitational pull of a planet, in this case Jupiter. The gravitational force decreases with distance, which means the side of the moon facing the planet is more strongly attracted, and the backside less so. And this difference in pull is called the tidal force. This tidal force causes the moon to deform, and this deformation can have two effects. Either the moon follows an elliptical orbit, and when it's closer to the planet, it gets deformed more strongly, and when further away, less strongly. This leads to a change in the deformation. On top of this is the fact that the moon is spinning too, whereby its orientation to the planet is always the same. And these changes in deformation result in the moon being heavily squeezed and stretched. The closer a moon is to its planet, the more heat is generated, as seen with Io and its volcanism. And when the moon is further away, less heat is generated, but often still sufficient for liquid water to exist. Oceans. And it's quite possible that life could arise in such oceans.
Scientists have been searching for extraterrestrial life for a long time, and now the focus is on Europa. This moon is a prime candidate because the ocean, which scientists presume lies beneath its ice crust, is vast. It may contain twice as much water as all the seas here on Earth put together. Its size and gravity are right too, so the conditions are favorable.
When I say life, I don't mean aliens and little green men and the like. We scientists would be happy to find life of any kind, like bacteria. A simple system that can self-replicate and reproduce. We would be literally over the moon just to find that.
Scientists believe that the ice crust covering Europa's ocean isn't all that thick. Who knows what might have developed beneath it?
If there's an ocean beneath this ice crust, which is well protected against the radiation in the Jupiter system and the solar wind, and which is in contact with the rocky core of the moon, the water will dissolve the rock and become enriched with salts. And it will become enriched with nutrients too. Oceans, as we can see from the Earth, are where life has a home field advantage and where it has the greatest likelihood of developing. Which is why Europa is at the top of the list when it comes to places where there could be extraterrestrial life today.
It's possible that the conditions in Europa's ocean resemble those in the deep sea on Earth. Here, extremely hot water full of minerals streams out of the ocean floor from vents called black or white smokers. No place for life, you might think. But it's home to so-called extremophiles, organisms that are adapted to the extreme conditions. Something similar is imaginable on Europa, too.
I think the Earth is always good as an example. And what exists on Earth under extreme conditions may exist elsewhere too. The conditions on Europa could be similar to those we find in the deep ocean and by these black smokers on Earth. Whether or not something has developed there and how, and whether it's similar to what we can find on Earth, or if there's much greater diversity, is something we'll only find out when we can gain access to this ocean.
The study of extreme organisms on Earth is still a relatively recent field of research in biology, with connections to astrobiology.
Wir finden sehr viele exotische
We're still discovering a great many exotic forms of life on Earth today, so we don't even know our own planet yet. This means that there may, of course, be forms of life in our solar system, and even on extrasolar planets that we can't imagine right now. So we need to do a great deal of research and keep an open mind.
Wir müssen offen bleiben.
Open to forms of life that are not dependent on the environmental conditions found on Earth, i.e. a certain temperature range and liquid water, oxygen and carbon as the most important ingredients.
Astrobiology also considers other forms of life, and I think that's very important. People have to remain open-minded to things they're completely unfamiliar with. We can't simply check for what we know and say we found it or not. Astrobiology takes a broader view and wonders whether completely different forms of life are possible.
The so-called cryovolcanism on Europa could provide clues as to whether life is developed there. Cryo means cold. We're talking about ice volcanoes. A moon like Europa that gets squeezed and stretched by Jupiter has beneath its ice crust an ocean that is in motion. When the ice crust breaks or cracks somewhere, water and alluvium spray out like the magma in a hot volcano and quickly freeze in the vacuum of space to form ice crystals.
This process is always the same. You have cold space and a hot body, irrespective of what cold and hot is. Space is cold, 200 to 250 degrees Celsius below zero, and the bodies are warm, regardless of whether they're 1,000 degrees or just 10 degrees Celsius. There's always an enormous temperature differential that wants to achieve equilibrium.
The vented water, ice, alluvium, etc., is easier to examine than the ocean itself and may contain evidence of life. NASA wants to investigate more closely. The Europa Clipper mission is planned for the late 2020s or early 30s. The probe is to orbit Jupiter on a highly elliptical trajectory and fly by Europa 45 times in order to assess its so-called habitability, whether the conditions for life are met. The probe won't orbit Europa directly, however.
They're flying to Europa, but they can't inject the probe into orbit around Europa because it wouldn't survive. So now they're planning on making a close approach and then flying way off again, and then flying close again, and doing this a number of times so that they get to observe Europa from all sides. Jupiter is like a massive particle accelerator. You're more or less sitting in the middle of a nuclear reactor when you get nearer, and a spacecraft can't readily withstand that sort of punishment.
The European Space Agency ESA wants to set out even sooner. It christened its mission the Jupiter Icy Moons Explorer, or JUICE for short. A probe will investigate the large Jupiter moons and fly close by Europa a few times.
The details of the JUICE mission haven't yet been finalized, but obviously it must have all the necessary instruments on board to measure things like atmospheric changes, radiation, temperature, and analyze the different regions of the electromagnetic spectrum. So it'll be a very complex mission.
After the flybys of Europa, the probe will then insert into orbit around Ganymede, which is further away from Jupiter and therefore not subjected to such hazardous radiation.
Ganymede is an enormous moon. It's much bigger than our moon. It has a diameter of around 5,300 kilometers, so it's really huge. We think that the conditions there may be conducive to something like life, though not on the surface. The radiation caused by Jupiter is far too strong for that. But it could be that we find something that surprises us.
Another hot contender in the search for extraterrestrial life is Enceladus, a small moon of Saturn, dazzlingly white, that was investigated by the NASA probe Cassini. Not much was known about Enceladus until the scientists studied Cassini's images more closely and discovered something unexpected. They found strange markings on the surface that they nicknamed tiger stripes, and more curious still, plumes of water that shot out into space.
Enceladus has a shell made from ice, but at the South Pole, there are cracks in the ice crust where water is ejected. The water then falls back down to the planet as snow.
Most celestial objects are dark. Enceladus, however, is dazzlingly bright and reflects more than 90% of the incident sunlight. This is because its surface dynamics result in a continual deposit of snow and ice.
Cassini
flew by and fairly quickly confirmed that this hypothesis is correct. It's volcanically active. We would regard it as something comparable to the geysers we're familiar with from Iceland. Enormous plumes of water are shot out into space, along with the vast quantities of ice particles. All sorts of stuff flies out too. There's methane and more complex hydrocarbons as well, but it's mainly ice, and this ice rains back down onto the surface.
But not all of the ice falls back on the moon. The remaining particles have a very specific role to play in Saturn's system.
Das Wasser, was zum Beispiel von Enceladus auch abgesondert wird.
The water that gets ejected by Enceladus also feeds Saturn's rings. The material isn't lost. It orbits Saturn and ends up feeding the rings.
Saturn herum und speist beispielsweise auch die Ringe des Saturn.
The particles shoot out at high speed. There must be an ocean beneath the ice crust.
Whether it blankets the interior or there's just a small pocket is unclear. Probably the latter. But it's not big. The energy for this ocean and the volcanism can only come from tidal friction with Saturn. And I mean, it's when I say not big, it's 500 kilometers in diameter. That's like from Berlin to Munich. So it would fit comfortably within Germany.
Although Enceladus is small, many scientists speculate, or hope, that life could have originated in this ocean. Extraterrestrial life.
Ich vermute, dass man als erstes Leben auf Enceladus entdecken wird. Man wird nämlich eine Sonde durch.
We'll send a probe through these water plumes that have formed along the ice fissures and extend kilometers into space. An element analysis may show amino acids, more complex compounds, and even organic material. And then we'll conclude that this moon is home to primitive life. That's my prediction, that it'll be where we first discover extraterrestrial life.
Der Erde Leben finden wird.
Enceladus is one of Saturn's 82 known moons, and not the only one that was investigated more closely by Cassini.
Cassini really was a fantastic mission. Very complicated, but nonetheless successful. Thanks to Cassini, we know now the detailed structure of Saturn's rings and how they formed. In addition, Cassini discovered a lot of new moons and flew by many of them. But the highlight was the ESA probe Huygens. The probe entered Titan's atmosphere and landed on the moon's surface, and it sent back absolutely stunning pictures in the process.
While descending through Titan's atmosphere, Huygens filmed a fascinating world that appears both totally alien and strangely familiar at the same time. Landscapes that are somehow reminiscent of Earth. Titan is the only object in the solar system besides the Earth where liquids persist on the surface. There are even rivers and lakes. The big difference? On Titan, it's a chilly minus 180 degrees Celsius. At these temperatures, the lakes are not comprised of water, but liquid methane. And cryovolcanoes eject not hot lava, but an icy slush.
Titan is interesting because it has a nitrogen atmosphere with methane clouds and methane fog on its surface. The temperatures are inhospitable to surface life, as they are far too cold.
Huygens' descent meant an almost unbearable wait for the scientists involved, because it takes so long for the radio signals from the probe to reach the Earth.
You're sitting on the Earth and have to wait 90 minutes to find out whether it's worked or not. So it's incredibly exciting. And what was sent back was breathtaking, at least for me. The first images were of it flying into a somewhat larger valley. You can see a coastline. You can see rivers that flow into this valley plain. It looked like you were flying with a plane along the North Sea coastline on a rainy day, because the atmosphere is extremely dense. It really was incredibly exciting.
The Cassini-Huygens mission was a textbook example of successful international cooperation in space. Cassini was a NASA probe that carried the European Huygens lander to Saturn on its back. Once there, Cassini then acted as the lander's radio relay station. NASA plans to return to Titan in a few years. This time, they want to send a quadcopter, that is, a robotic rotorcraft. The mission's name? Dragonfly. This Dragonfly will spend 2 years flying around exploring the various regions of the Moon. It should also ascertain whether precursors of life are present in the frigid methane lakes.
Imagine you went on a mission to Earth and landed in the Sahara. You wouldn't get a representative picture of the planet as a whole then, so you have to be able to travel around large areas. And you could do that with a drone, and a drone could fly on Titan too, because Titan is the only moon with an atmosphere. In order to fly, you always need an atmosphere in order to generate lift, like propeller aircraft can fly here on Earth.
Another of Saturn's moons was puzzling scientists because it seemed to regularly disappear and then appear again. Its name? Iapetus. Thanks to Cassini, we now know that the front side of the moon is as black as soot and the back as bright as ice. When the dark side is facing Earth, the moon becomes practically invisible. Why the two halves are so different remains a mystery. In addition, the moon has a mountain ridge on its equator that makes it resemble a walnut. How this mountain ridge formed is not yet known either. A neighbor of Iapetus is the moon Mimas. Nothing special really, but it has many fans because it resembles the Death Star from Star Wars. And then there are the so-called shepherd moons of Saturn, small moons that keep Saturn's rings in shape. These moons herd the ring particles like shepherds herd their sheep. Planets like Jupiter and Saturn generate tides on their moons, thereby producing heat. These tides have yet another effect, though, as we see from our moon.
Tidal forces have a very interesting long-term consequence, because the internal friction causes the speed of rotation to decrease. This means that the moon spins ever slower. How long does this go on for? Well, it goes on until the rotational period of the moon matches its orbital period around the planet. At this point, the same side of the moon always faces the planet. This is called a tidal orbit. And because the moon's rotation is synchronized with its orientation, it doesn't get stretched and squeezed anymore. Heat is no longer generated, and the moon cools down. This has happened to our moon. Incidentally, tidal orbits like this occur throughout our solar system, including the case of the Martian moons Phobos and Deimos.
The effects of these tidal forces is even more obvious with Pluto, the dwarf planet at the edge of the solar system. Pluto has a moon named Charon, whose diameter is half that of Pluto. The tidal effect is so great that both bodies are tidally locked with one another. The same side of the moon Charon always faces Pluto, and the same side of Pluto always faces its moon.
They each spin once about their respective axes for each complete orbit about their mutual barycenter. So they're both tidally locked to each other. Pluto and Charon always present the same face to one another.
The NASA probe New Horizons flew close by the odd couple in the summer of 2015. Instead of the expected dead rocks, it found two fascinating multicolored worlds dancing around one another. Triton is also a strange moon. It orbits its planet, Neptune, backwards. Triton is another large ice moon, presumably with an ocean beneath its ice crust. Its orbit is retrograde, which means it orbits in the opposite direction to its planet's spin. The question is, how did it come to be in this orbit?
When a system like this forms, Jupiter, Saturn, Uranus, Neptune, it's from an accretion disk that rotates. And when moons form in it, they naturally rotate in the same direction as this accretion disk, or in this case, the planet rotates. When its orbit is retrograde, it's not as straightforward. Retrograde anomalies can happen when a moon is captured. This means a foreign body traveling on a different trajectory approached Neptune too closely, got slowed down, and forced into its orbit.
The surface of Triton is an icy minus 235 degrees Celsius. No other moon in the solar system is colder. NASA scientists would like to investigate Triton with the probe too. Up to now, we only have the images taken by Voyager 2 as it passed by in the summer of 1989. The new project, named Triton, has to compete with other projects for the available funding, however. Humans have zero chance of survival on planets like Jupiter or Neptune. Their gravity and pressure are much too high. The situation is different on the numerous moons of these planets, however. Is it conceivable that we could settle there in the future? Or are these just science fiction fantasy?
Do colonies on moons make sense? Yes. But the moons would have to be at least as large as Earth's moon. Take Phobos, the largest of the Martian moons. It's so tiny that its gravity is just 1,000th that of Earth. A small jump and you'd float off into space. Moons as raw material stockpiles? Well, I don't know of any moon that consists solely of gold and diamonds. And we have enough of all the other raw materials on Earth. They could be a good launch pad for space stations. And one final thought. Could there be exomoons somewhere out there? That is, moons orbiting exoplanets. We know today that this must be the case. There have to be a lot of moons out there. But because they're so small, smaller than the exoplanets, they're extremely difficult to detect. But let's wait and see. Maybe we'll manage to in the future.
Some moons are just lumps of rock, barren and empty. Others are absolutely fascinating. Io has more volcanoes than any other object in the solar system. Titan amazes with icy river and lake landscapes. Europa, Enceladus, and Triton have oceans hidden beneath their thick ice crusts. Could exotic life forms swim in these oceans, perhaps? The moons of our solar system, the silent companions of the planets, are unique worlds in their own right, full of mysteries just waiting to be investigated. The probes we send out are getting increasingly sophisticated each time. And who knows, maybe humans will fly there one day themselves. Not to mention all the exoplanets out there in the Milky Way. a great many of which probably also have exomoons with mysteries of their own.